In this video, we're going to learn about similar polygons. Figures that are similar have the same shape but are not necessarily the same size. So if you look at our two houses, they're the same, but one is bigger than the other. So this is just like the drawings we started yesterday. Eventually, we'll have those put up and taped together, and you'll see that we had a small coloring page, and we each drew a section, and once they're all taped together, we'll have a larger one that's hopefully almost the exact same, just bigger. In order for two shapes to be similar, they have to have corresponding angles that are congruent. So if you look at our statement down here, this is called a similarity statement. It says that ABCD is similar to HIJK. So this little squiggle in the middle means similar. And so that tells me that since A and H are both listed first, those angles would be congruent. So I'm just going to mark those figures. And then B would be congruent to I, C would be congruent to J, and D would be congruent to K. So that's the first thing that we have to have in order to know that two shapes are similar. The second thing we need is that corresponding sides are proportional. So if I look at side AD, it's 2. It corresponds to HK, which is 4. And if I made that a proportion, 2 over 4 is a half. So if I look at AB, the top side, it corresponds to HI, and so that'd be 3 over 6, that's also 1/2. And so each of the other sides should follow this pattern and all be proportional, so they should all equal 1/2, and they do. And so those are the requirements for similarity. In this first example, we have a similarity statement. So it says triangle MNP is similar to triangle SRT. And it asks what pair of angles are congruent. And so angle M would be congruent to angle S because they are both listed first. Angle N would be congruent to angle R because they're both listed second. And angle P would be congruent to angle T because they're both listed third. Then it says, what is the extended proportion for the ratios of the corresponding sides? And it might help you if you have a picture. So the first triangle was MNP, and the second triangle was SRT. And so this is asking if we were going to set up our proportions, what would they look like? And so we have side MN, which would correspond with RS. So I would put those two sides in a proportion. The second sides that go together would be NP and then RT. So that would be my second part of the proportion. And the last side would be MP and ST. And so extended proportion just means it's going to be more than 2, and it would look just like what we have written out here. Example 2 asks, are the polygons similar? If so, write a similarity statement. So there were 2 things I needed to check. 1, are the angles congruent? So if I check, I've got J and T with 2 marks, so that matches up. Then I have K and U are both right angles, so that matches. V has 3 marks and L has 3 marks, so that matches. And W and M both have 1 mark, so those are also matching. So yes, our angles are congruent. The second thing I need to check is, are the sides proportional? And so how I'm going to check that is by setting up a proportion for each side. So if I start with JK and then this TU, I would have 12 over 6, which is 2. And then I go to the next one, so KL and UV, so 24 over 16, which does not get me 2. And at this point, since I have one that's 2 and one that's not 2, I know they're not proportional, so I can just say not proportional. If they're not proportional, you can't have a similarity statement. Since they're not proportional, we're going to say not similar. For this next example, we're going to do the exact same thing. So it says, are the polygons similar? If so, write a similarity statement. If you look this time, my triangles aren't oriented the same way, so it can get a little confusing, but we'll check our angles first. So we have C has 1 mark and F has 1 mark. A has 2 marks, D has 2 marks, B has 3 marks, E has 3 marks. Angles are congruent, so we check off that box. That works out. Next, we need to check sides are proportional. And to do that, we're going to have to think about which sides are corresponding. I like to just go with numerical order. So for example, 8's the smallest on this triangle, and the smallest on this triangle is 10. So those two sides would need to be what I compare. So that would be 4/5. My second smallest side is 12. And then on the second triangle, it's 15. So I would want to compare those two next. So 12 over 15 would simplify to be 4/5. And then lastly, my largest side is 16 and 20. So 16 over 20 also simplifies to be 4/5. All the sides are proportional, so these are similar. And then we would need to write a similarity statement. So I could say triangle CAB is similar to triangle FDE. In example 4, it says ABCD is similar to EFGD. What is the value of X and Y? So if these are similar, which they are, we know that the sides are proportional. And so we can set up a proportion to find these missing sides. So you just are going to choose a set of sides that has numbers. So for example, this DE side here corresponds to AD. So I would start my proportion with 6/9. And then it asks me to find X and Y. So since I put the smaller shape on top with the 6 value, over here I would put X on top because it's also part of the smaller shape. And it corresponds to, on the larger shape, this 7.5. So now I've set up a proportion, and we know from last week that we solved this by cross multiplying. So I would do 9 times X, which is 9X, and 6 times 7.5, which is 45. I would divide both sides by 9, and X is 5. And you can kind of think about if that makes sense, because I know that this X is supposed to be smaller than the 7.5 side, so that does make sense. I'm going to do the same thing for Y. So I'm going to use my 6/9, and then I put Y on top because it also is the part of the smaller shape, and it corresponds to 5. And so I'm going to cross multiply. 6 times 5 is 30. 9 times Y is 9Y. And if I divide both sides by 9, I get 3.3 repeating. For the next problem, it says a class is making a rectangular poster for an event. The poster design is 6 inches high by 10 inches wide. So you might just want to sketch yourself a picture. So I have a poster that's 6 inches by 10 inches. It says the space allowed for the poster is 4 feet high by 8 feet wide. So 4 feet by 8 feet. What are the dimensions of the largest poster that will fit in the space? And so the first thing I'm kind of thinking about is that I have two different units, so it might be a good idea to convert these feet into inches. And so this is really 48 inches by 96 inches. If you kind of think about it logically, instead of doing a bunch of math, I have this 6/10, and I'm trying to fit it into a 48 by 96 space. It doesn't have to fit perfectly. I'm just trying to figure out what the largest size poster that I could fit would be. And if you just kind of think logically, 6 times 8 will get me 48. So if I were to do the same thing to the bottom, it would be 80. And so the largest poster I'm going to be able to get is a 48 inch by 80 inch poster.